Hi there and welcome to today's class. For today we'll be looking at the organic chemistry experiment 2.4 solution, and experiment 2.4 is simply the oxidation of alkanols with potassium permanganate. Alright, so you have the procedures here, but I'll just jump straight to answering the questions. Alright, question section here. Questions. Question 1: which reaction or reactions did you observe? Question 1: what reaction or reactions did you observe with each of the given samples? Right, so you're given three samples here, sample A, sample B, and sample C here. Right, you're reacting alkanols. One of the sample will be a primary alcohol or alkanol. One of the sample would be a secondary alcohol or alkanol, and the third one would be a tertiary alcohol or alkanol. Now, when you do the experiment, number one, they said which or what reaction or reactions did you observe with each of the given samples? Now, from this one here, okay, this one said sample A, there was no reaction. So when it is sample A, there was no reaction. Sample B, a color change was observed and reaction was fast. While sample C, when we did sample C reaction with potassium permanganate, the color changed from purple to colorless and a sweet smell was observed. Now, this is just an illustration of how you should report your answer. Okay, they could switch these samples in any year, so don't just copy this from what you did in your lab, right? What did you observe? So you're just simply to write out your observation here. Another way of expressing this whole thing would be, now before then, if you look at this, it said sample A there was no reaction. So it was more like sample B and sample C. There was a kind of reaction. So sample B and sample C reacted, but sample A did not react. So an alternative way of reporting this experiment or of reporting these reactions would now be that. All right, so will now be that question one, we can say oxidation or oxidation reaction was observed in sample B and C, right? While sample A did not react. You see the same thing, all right? So this is like a simpler way of giving your answer. So we know that sample B and C reacted, but sample A did not react. Again, there's no guarantee that in your own or when you're watching this, it would be sample B and C. It could still be A and B or C and A or whichever way. But make sure you're answering the question from the observation you had in the laboratory. Okay, so this should just be like a guidance on how to answer them. All right, so let's proceed to the next question. Number 2 says, given that A, B, and C were either 2-methyl 2-propanol, ethanol, or 2-propanol, write equation or equations for one or for the one or ones that reacted, and give reasons why the other or others did not react. Hence, identify A, B, and C. So in this one here, we have to give the equation of the reaction. Then don't forget that two samples reacted while one did not react, right? And from the equation, we have to determine which of them is a primary alcohol, secondary alcohol, or tertiary alcohol, right? All right, so let's get this done. All right, so we'll start with 2-methyl 2-propanol reacting with potassium permanganate. So question 2, let's start with 2-methyl 2-propanol plus potassium permanganate. All right, let's write out the equation for this. So 2-methyl 2-propanol would be this, simply CH3 C into CH3 OH and then into CH3. All right, so this is the condensed formula for 2-methyl 2-propanol. If I react this with potassium permanganate, Now, this is a tertiary alcohol, and when I reacted this, what you observe is that there's no reaction. So the answer here is no reaction, or we can say no reaction occurred. All right, no reaction occurred. All right, so this is the first one here. No reaction occurred. All right, let's look at the next one there. The next thing there was ethanol. Okay, so it was ethanol reacting with potassium permanganate. So let's get the next one there. So let's call this I. So I now. I ethanol reacting with. All right, so let's get this done. So for the ethanol, what I will have is simply CH3 into CH2 into OH. So this is ethanol. Ethanol combines with potassium permanganate. So if I combine ethanol with potassium permanganate, what do I get? This would now give you the product here would be an ethanoic acid. Now, what to notice this, if I combine this with potassium permanganate, first of all, I'll get, so if this reacts, first of all, it gives you a ketone, and the ketone here would be CH3 into C double bonded to O and then H, or better still, you can write this as double bonded to O upwards and then H. So I have this. This is a ketone, all right? This is a ketone. Then on further reaction, so you have another one there. On further reaction with potassium permanganate, okay, so KMnO4. On further reaction with this, you now have an ethanoic acid, which is CH3, CH, or better still, CH, that gives you CH3, C double bonded to O, and then OH. So I have this. All right. So this is what you have. We could name this. This would be ethanoic acid. Ethanoic acid. This would be this compound here is a ketone. More still, it can be called ethanol. All right. Okay. Of course, this one here is your ethanol. While this is your potassium permanganate. All right. So you can indicate here potassium permanganate. Potassium permanganate. All right. By the way, for this one here, we didn't name this, but you know that the name for this one here is 2-methyl, 2-methyl, 2-propanol. This one here is potassium permanganate. Potassium permanganate. So I have this. Of course, we said it will give you no reaction. All right. All right. So this is for the second one. The third one there, I. Let's take I. The third one there. Now for the third one, what do you have here? For the third one, we have that 2-propanol. All right. 2-propanol is reacting with potassium permanganate. So I have 2-propanol, propanol combines with potassium permanganate. So what do we have? So for 2-propanol, your formula, right, the condensed formula for 2-propanol is this: CH3 into CH into CH in brackets OH, then we now have CH3. So this is 2-propanol combines with potassium permanganate. All right, if these two combine, what do we have? I'll have this. So what I'll have here would now be 2-propanone, 2-propanone here, which is CH3 single bonded to C upwards O, then here becomes CH3. All right. So if you're to name this, the first thing I have here is 2-propanone, 2-pro, 2-propanone. Okay, that's your major products. Anyways, there are some minor products, but these are like your major products. So I'll have 2-propanone here. What we had here is potassium permanganate. Then what we have here is 2-propanol. So we have 2-propanol here. All right. Let's shift this. All right. We have here as 2-propanol. So basically, you have these three equations. All right. So these are the required equations. All right. Let's proceed to the question again. So what's the next task there? Next task there says, why did the others why the others said, and give reasons. Okay, so and give reasons why the other or others did not react. So why did, if you look at this, I said the first one here, no reaction occurred. So why was there no reaction here, right? The answer is simple. Let's give reasons. Now your answer is this: 2-methyl 2-propanol did not react because it is a tertiary alcohol and therefore does not readily undergo oxidation. All right, so please take note that tertiary alcohols do not readily undergo oxidation. Meanwhile, these reactions are actually oxidation reactions, and since tertiary alcohols do not readily undergo oxidation, then we can say, and this is why 2-methyl 2-propanol did not react, because it's a tertiary alcohol, and tertiary alcohols do not readily undergo oxidation. All right, so let's look at the next question there. Okay, so before that, we also asked to identify sample ABC. All right, so before question 3, we asked to identify sample ABC. Let me do that one here. So let's say sample A, I'll just do it here instead. Sample A, what's sample A exactly? Now, for ABC, one of them is a primary alcohol, one of them is a secondary alcohol, and the other one is a tertiary alcohol. So let's see which would be which. Now, let me use this same thing here. Sample A says there was no reaction. And don't forget that when we say no reaction occurs for tertiary alcohol. So we can say sample A is a tertiary alcohol. Is a tertiary alcohol because there was no reaction. And of course, you can indicate it here. Which of them here is a tertiary alcohol? That's 2-methyl 2-propanol, 2-propanol. All right, so 2-methyl 2-propanol is sample A. Let's look at sample B. Let's look at sample So for sample B, now if you look at this, one of the distinguishing factors is that sample C had a sweet smell, all right? And sweet smell are only from the ketones, all right? So the ketones, which in this case is 2-propanol, gives you a sweet smell. So most likely sample C is 2-propanol, and 2-propanol is actually a secondary alcohol. Hence, we are left with the primary alcohol, which will now be sample B. So I'll now say sample B is a primary alcohol, is a primary alcohol, and my primary alcohol here amongst these three would be ethanol. So I have ethanol. All right, so we're left with sample C. So in this case now, sample C is a secondary alcohol. Right, the secondary alcohol here from the given reactants here is just 2-propanol. That becomes 2-propanol. All right, so with this, we have identified A, B, and C. Now, get the reason why we got this identification. The first one is that sample A is a tertiary alcohol, and the reason is because it did not react. Because tertiary alcohols do not readily undergo oxidation reactions, and then out of these given samples, 2-methyl 2-propanol, ethanol, and 2-propanol, the tertiary alcohol here is 2-methyl 2-propanol, and that's how I got the first one there. For the second one, I was left with sample B and C, in which one will be primary, one will be secondary. And I knew that sample C was secondary. Why? Because when we oxidize a secondary alcohol, it gives you a ketone, and a ketone has a sweet smell. So going through my question 1 here, we said sample C had that sweet smell. Okay, so the sweet smell comes from the sample C, which is the secondary alcohol. So since sample C gave me a ketone, which gives a sweet smell, it was obvious that sample C is a secondary alcohol. Now, if sample A is tertiary, sample C is secondary, we are left with sample B to be primary. And from the reactants given, the secondary alcohol is 2-propanol, while the primary alcohol is ethanol. So this is how I identified it as A, B, and C. All right. So with this gotten, let's look at the third question. Question 3 says, name the product or products in your equation or equations in question 2 that gave rise to the smell you observed in the reactions. What smell? Again, the sweet smell. So the product that gave rise to this sweet smell was 2-propanol. Of course, the 2-propanol is a ketone. Ketones usually have sweet smell. Let me ketone. All right, that gave rise to the sweet smell you observe. So the answer is 2-propanol. That's the product. All right, so the last one here is write an equation for the oxidation of this by the procedure in this experiment. What procedure exactly? Now, for this experiment here, we were reacting alcohols with potassium permanganate. So if they say we should write an equation for the oxidation of this, is simply combine this one here with potassium permanganate, and let's see what you have as your product. All right, so let's get to this. All right, so question 4. So for question 4, we have this. We had a reactants there, H2C double bonded to CH single bonded to CH2 and then OH. Right. Combine this with potassium permanganate. What do we get? If I combine this, my product would be, so for the first one, when I combine this is what the product would look like. the product here would be, all right, so my product would look like this: H2C, upwards I'll have OH, single bonded to C, upwards I'll have OH, then I'll have H here. Okay, to my right I'll have a carbon here, double bonded to oxygen, and then I'll now have OH here. Alright, so this is what my product would look like. Alright, so this is what we have when we react these two from question 4. Alright, so this is how we answer this question. Please, if you enjoyed this video, don't forget, always hit the like button. Alright, so give us a thumbs up. It helps us to grow. Also, leave a comment. Tell us if you enjoyed this experiment or this video solution. And of course, suggest other experiments you would have us do. Don't forget too, you can subscribe to this channel if it's your first time visiting. And don't forget, share this video to your friends so that they can also learn. Thank you and see you in our next class.